Hi there, folks. So, let's see, I just recently wrote an article and submitted it to medium.com, and let's see, minus one little error there. There we go. Alright, anyway, I figured it would be helpful to go through the exercise of explaining what this was all about, so it's a little easier to see it perhaps than in the article. But in this examination we're going to be looking at 5 against 4 or 5-4 polyrhythms, and how this works is just as I described in the article. Each one of the black lines here represents a tick, and you'll notice that the total quantity of ticks for each of the rows here is a product. The number is a product of 5 times 4. So we have 20 ticks total. And that's really the magic behind being able to construct these arbitrary polyrhythms. Essentially, just coming up with a multiple that's common to both of the time figures that you want to get to that's the secret to making this work. So anyway, obviously this whole thing is repeated. That's what the repeat signs are all about in the ends there. So one cycle essentially starts with our first tick there, and both limbs or hands or different instruments would be striking on the O's. So the O's are sounded, and the ticks are just the background time being kept. So let's see, another quick explanation. You'll notice in the 5 row, 20 divided by 5 is 4. So we end up having 1, 2, 3, 4 full counts under that first O. So the zeros are O's here. And then another group of 4, another group of 4, another group of 4, last group of 4. The 4 row, by contrast, is dividing into 20 5 times. So we have 5 ticks for every O. So there we go. That's the basic way that all works. And let's see, going through a couple of properties. Let me turn on my metronome, and hopefully you guys can hear that. Yeah, okay. Alright, so right now I've just got it set to 88 beats a minute, but well, now, one of the things I want to demonstrate, and hopefully the mic on the camera is good enough that you can kind of hear what's going to happen in stereo. Okay, now I'm going to do something here. I'm going to actually speed it up a bit, and we're going to check out what happens what happens when we start speeding it up? It actually develops its own lope. Okay, now taking it up again. Okay, so a couple of things that's interesting is, as you may have guessed when I was doing this kind of motion, you can actually hear the two time signatures, well, not time signatures, but time figures work against each other. And when one was louder, you got the definite sense that that was like a time signature. But the other component, its complement, was acting like an accent, a rhythmic accent. So what's interesting to me is that there are ways in which these complementary figures almost have the ability to have a sort of swing, a perceptual swing that can occur when you compare one as if it were an accented figure, accented syncopation against the other figure. So I guess technically it is a syncopation, but we don't always think about polyrhythms or tuplet figures as being like even a simpler form of syncopation. So anyway, let's see, the other thing, just a quick remark, you'll notice that this right here ends up being like a mirror image, right to left, and that's something that I found happens in nearly, well, actually in all of the polyrhythms that I've studied so far. There's some kind of a mirror image that happens from the inside, the middle, if you will, of the total count, reflected complementarily in both directions. So anyway, that's just using 5 against 4 as an example, and hope you find that a useful trick. When I figured it out 24 years ago, it kind of blew my mind that it was that simple. But anyway, hope you enjoy and have a great day. Keep on rocking.